All right. So remember, Thursday, last day to hand in any missed assignments. Also, Friday, January 20th, 8:30 in the morning. You need to be here for your final exam. This Friday, January 20th. Yes, sir. Can't hear you? I've never heard that. Yeah, I never heard that. What's that? Well, it's a regular school day. There's exams, so as far as I know, there's buses running the whole time. You can, but no bus will pick you up till after school. So that would be correct. Okay, so again, put it in your phone, in your calendar, so you don't forget. Because Wednesday is the last day of classes, so I won't be able to remind you on Thursday because you won't be here in this class. So Friday morning, 8:30, January 20th, that's in like 4 days or 3 days, is when your final exam is. On Thursday, there's nothing. You're not going to be here Thursday for me to remind you Friday because you won't be here Thursday. Wednesday is the last day of classes. So on Thursday, January 19th, you guys don't have, unless you have Social 10, so Social 10 in the afternoon, then you have to be here for that, right? But you will not be in my class on Thursday. I won't see you. Tomorrow will be the last day I see you till Friday morning for the final exam. Okay, so 7.5, here we go. So yesterday we talked about surface area of certain shapes like prisms and cylinders, etc., etc. So we're going to look at a couple more today. Surface area of pyramids and cones. Jackie, where's your package? Get it out. So that first shape is a square-based pyramid. So the base is a square, that's why it's called square-based, and the sides are triangles. Now, because it's a square-based pyramid, meaning we can say that both of the dimensions on the bottom are the same. So we can say L and L for length, the length of each side. It's a square, they're all the same. So because of that, the four triangular faces are also the same. And the formula for area of a triangle we saw a few days ago was base times height divided by 2. But there are 4 of them. Okay? There are 4 of them. So if we put that piece there, that represents the height of each triangular face. We can find the surface area, the area of all the faces added up by breaking it up into 2 different pieces or 2 different parts. Do you have a question, Lucas? Not on this unit, there will not be a test, but these questions will be on your final exam. Okay, so the first part we'll do is the bottom. It is L times L, which would be L squared. Plus, then we have 4 triangular faces, and they're all the same. So it'll be 4 times. Again, the formula for area of a triangle is the base, which we have as L, times the height, divided by 2. Base times height, and we've labeled the base of each triangle as L. So it's L times height divided by 2. So we can simplify this. L times L would be L squared plus, and then for the second term, you can divide top and bottom. 4 divided by 2 is 2. So we're left with 2 times L times H. So that is a formula that we will use for surface area of a square-based pyramid. The second shape there is a cone. And the formula for surface area of a cone is, it's the base, which is a circle, that's pi r squared, plus, now for the other part, in order to find the surface area, you need to know S, which is the slant height. It is the length of the edge of the cone, from the very tip down to any point on the base. That's what S is, the slant height. The other part of the formula is pi times r, the radius, times S, the slant height. That's the formula for the surface area of a cone. Okay, so I'm just going to do a couple examples from this lesson, then we're going to go on to the next lesson, which is the surface area of composite shapes, where you have a couple different shapes put together. So for question A, that is a square-based pyramid. And we saw above that the formula for the surface area of a square-based pyramid is L squared plus 2LH. Yeah, I know. Okay, so L is the length of each edge, which is 10 centimeters. So it's 10 centimeters all squared plus twice L, which again is 10 centimeters, times H, which is 18 centimeters. That is the height of each of those triangles. So we can go to our calculator and put this all in one step. It'll give us our answer. So we've got 10 squared plus 2 times 10 times 18. Again, your calculator will do order of operations for you. So that'll be 460. And remember that area is always in units squared. The unit in this case is centimeters, so it'll be 460 centimeters squared. Okay, so that's the surface area of that one. Now, if you go on to the next page, because B is the exact same, but C is a little bit different, and the reason for that is because we're not given the height of each triangular face. We're given the actual height of the pyramid. So we need to calculate what the height of each triangular face is. And to do that, you have to look and see what we have here is we have a right triangle. Let me just find a color that's going to show up nice in here. We have a right triangle that looks like that. And the hypotenuse of that right triangle is the height of the triangular face. This is a right triangle, like I said, right? This is going to be a right angle down here at the bottom. So we can use Pythagorean theorem in order to find out what the hypotenuse is, which would represent the height of each triangular face. So as it says there, The height of this triangle is 7.2 meters. And the base of the triangle would be half of 5, because this part that comes straight down actually comes from the very center of the base. Jackie, put your phone away. So the base of this triangle is 2.5 meters, half of 5. And so, like I said, we will use Pythagorean theorem to find out what the hypotenuse is, which represents the height of the triangular face. That's what h will be. So Pythagorean theorem says that a squared plus b squared equals c squared. Remember, a and b are the two legs of the right triangle. So it'll be 2.5 squared plus the height, which is 7.2 squared, equals c squared. 2.5 squared plus 7.2 squared is 58.09. That's what c squared is. And then to find c, we take the square root of both sides. Which is approximately 7.6 meters. So I rounded it to write it down, but when we use that number in a calculation, we have to use the entire value that's in our calculator. So I'm going to store that into memory slot A for now, just so I have it there. And now we can find the surface area of this shape by using the formula. Surface area will equal L squared plus 2LH. That's the formula we had on the previous page. L squared plus 2LH. So L represents the length of each edge of the base, which is 5 meters, plus 2 times L again, which is 5 meters, times H, which we found to be 7.6 meters. So we can put this all in our calculator. 5 squared plus 2 times 5 times the answer we got in memory slot A, an entire decimal, gives us 101.2. And I'm saying approximately equal to because we rounded. And area is always in units squared. Okay? So there's the surface area of that shape. Now, D is a little bit different because the base is not a square. In this case, the base is a rectangle. So we're going to have to change our formula a little bit, and I'm going to do it above here. The surface area of this will be found by 3 different parts. The base, which is a rectangle, so we can say length times width, length times width, plus, then we have 2 different sets of triangular faces, okay? Because we have different base dimensions, we also have different height dimensions of those triangular faces. And you can see the front piece has a base of 4.5 and a height of 6 feet. And the back piece is exactly the same. So we're going to have 2 of these triangular faces. So what I'm going to do is I'm going to say that H1 represents height that corresponds to the triangle with a base of L, and I'll say that the 5.8 is H2, height 2. It corresponds to the base of W. So the formula for area of a triangle is base times height divided by 2, but again, we're going to have 2 sets of each triangle. I'm going to do the front piece, which is the same as the back piece. There are 2 of them. That has a base of L, a height of H1, try that again, times a base of L times height 1 over 2, because the formula for area of a triangle is base times height divided by 2. The base is L, the height is H1. And there's 2 of those triangles. That's why I have the 2 in front. And then the same thing for the second set of triangles. The left and right sides has a base of W and a height of H2. Again, the formula for area of a triangle is base times height divided by 2. But there are 2 of each. So what happens here is the 2's cancel for those last 2 terms. 2 divided by 2 is 1. And that's the equation that we're left with to find the surface area of that shape. So I'm not going to put the units in. I can. I'll just use the symbol. 4.5 times 3.5 feet for the base, plus L, which is 4.5 feet times H1, which is 6 feet, plus W, which is 3.5 feet times H2, which is 5.8 feet. So this last piece is 5.8 feet. And so we can put all these in our calculator in one step. Your calculator does order of operations. So the first term is 4.5 times 3.5 plus, then we have 4.5 times 6 plus 3.5 times 5.8. Altogether 63.05. And that would be in square feet. Okay? So there's the surface area of that one. So these next 2 are cones. And the formula for surface area of a cone we found was pi r squared plus pi rs. And once again, all of these formulas will be given to you on the formula sheet. You don't have to memorize them. They will be given to you. Yep. Hang on a sec. For D, 63.05. Yep. All right. So remember that r is the radius, which in this case would be half the diameter. Right? In this case, we're given the diameter to be 7 centimeters. So that would make r the radius, half of 7, which is 3.5 centimeters. And s, the slant height, is 11. That's the length along the edge of the cone. That's what the slant height is. That's what s is. So pi times the radius of 3.5 centimeters squared plus pi times the radius of 3.5 centimeters times s, the slant height of 11 centimeters. So because our formula involves pi, that's an irrational number, our answer is going to be irrational. It's going to be a decimal that we have to round. That's okay. We can do that. So pi times 3.5, whoops, try that again, 3.5 squared plus, once again, pi times 3.5 times 11. So 159.4 if I round to the nearest tenth. And that would be in centimeters squared. And that next cone is virtually the same, except in this case, we're actually given the radius, not the diameter. So you're just going to let r be 18 and s, the slant height, be 30, and you'll get your answer. Let's go on, though, to question G. For question G, you're not given s, the slant height. You're given h, the actual height of the cone. But like we saw with our pyramids, sometimes we need to use Pythagorean theorem to find a missing dimension before we can find surface area. And that's what we need to do here. This is a right triangle. Between the radius and the height of the cone, the slant height s is the hypotenuse of that right triangle. Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the 2 legs of the right triangle. In this case, 1.5 feet. That needs to be squared plus 3.6 feet that needs to be squared, and that will equal c squared, which I'll now put an s in there for c, because that's what that hypotenuse represents in this cone. It represents the slant height. So 1.5 squared plus 3.6 squared will give us 15.21 on the left side, and that'll be square feet. That's what s squared equals. To get s, we get rid of the square by doing the opposite of square rooting. And we'll take the square root of 15.21. The previous answer gives us exactly 3.9. Don't have to round that, which is nice. But there's s, our slant height. So now we can find our surface area. Again, the formula is pi r squared plus pi rs. And once again, these formulas will all be given to you on a formula sheet. You don't have to memorize them. The radius of this is 1.5 feet. And we found s, the slant height, to be 3.9 feet. So pi times 1.5 squared plus pi times 1.5 times 3.9, approximately 25.4. Again, because this number involves pi, you're going to get an irrational number, a non-repeating, non-terminating decimal, which will round to the nearest tenth, 25.4. Bless you. Okay? All right. So let's go on to 7.6. So remember, these composite shapes are where you have two or more shapes put together. And we want to find the surface area. Now, what you have to realize is that surface area is only the pieces that you can actually see. When two shapes are put together, where those two pieces come together, that's not going to be calculated in the surface area, because it's only the parts that you can see. If you pick it up, you can turn it upside down, or you can see the bottom of this shape. But the bottom of the pyramid and the top of the box are not visible, so those pieces would not be included. It's only the pieces that you can physically see. So that means that we have to do some adjustments to our normal formula. For example, I'm going to split this into two pieces. Let's say the bottom, the box, is surface area 1, and the top, which is the pyramid, is going to be surface area 2. For the bottom, we're going to have the very bottom of the box, which is 6 by 6, 6 meters by 6 meters. And then we've got 4 rectangular sides, and they are all equal rectangles. They're all 6 meters wide by 4 meters high, and there's 4 of them. And the formula for area of a rectangle is base times height. But again, in this case, there's 4 pieces that measure 6 meters by 4 meters. So 6 times 6, or 6 squared, plus 4 times 6 times 4 is 132. And that would be in meters squared. Go ahead, Jeff. So that's the first part of this. And then we're going to have the top part, which is surface area 2. The top part is made up of 4 triangular faces. Again, you cannot see the bottom of that pyramid, so you can't include it in the surface area. because we're looking for the area of all the faces that you can see. So all you can see are the 4 triangular faces, and they're all equal triangles because they have the same base of 6 meters. So all the heights will be the same as well, 8 meters. So 4 triangles, and the formula for area of a triangle is base times height over 2. You can divide 4 by 2, and that'll leave you with 2 times 6 times 8, which is 96 meters squared. And so now we will add these two together. The actual surface area will be 132 meters squared plus 96 meters squared gives us 228 meters squared. So there's the surface area of that composite shape. Yes, sir. One final. And you use your calculator on the whole thing. Okay. Looking at the next one. Again, there are 2 shapes there. There's a cylinder on the bottom, and there's a cone on the top. Okay? So, if we split this up into 2 surface areas, let's say the bottom is surface area 1, the top surface area 2. The bottom, again, is a cylinder. And yesterday we saw that the formula for surface area of a cylinder was 2 pi r squared plus 2 pi r h. That's the formula we had yesterday for surface area of a cylinder. And we talked about the fact that you need to understand where the different parts of the formula come from. The 2 pi r squared part are for the surface area of the circular top and bottom. However, in this case, you can't see the top of the cylinder because that's where the cone is attached to the cylinder. You cannot see the top of the cylinder, nor can you see the bottom of the cone. So you will not use those parts to calculate surface area, which means that instead of 2 pi r squared, it's only going to be 1 pi r squared, only the bottom. You cannot see the top of the cylinder. Are you with us, Charlie? So that's why I crossed off the 2. The radius of the cylinder is 3 yards. So there's pi r squared plus 2 pi times r, which is 3 yards, times h, the height of the cylinder, which is 5 yards. So that's what we're going to put in our calculator to calculate the surface area of the bottom piece. So it's pi times 3 squared plus 2 pi times 3 times 5. So there's the surface area of the bottom piece. Oh, I did, thank you. So let's fix that. Should just be 3 times 5. So we'll delete that. There we go, that's better. 122.5. Pi times 3 squared. Yeah, 122.5, which is rounded. And that is in square yards. Now, I'm going to store that into memory because I know I have to add it to the top piece. The top piece is a cone. And we saw that the formula for the surface area of a cone is pi r squared plus pi rs. The pi r squared part, though, represents the bottom of the cone, which is a circle. But you can't see that. Right? That's where it connects to the top of the cylinder. You cannot see the bottom of the cone. So we're going to cross off the pi r squared part. We're only going to use the pi rs part. Pi times the radius of 3 yards times s, the slant height, which we are told is 5 yards. That's what the 5 is. It's the slant height. So pi times 3 times 5, which is 15, 47.1 approximately. And again, when we calculate our total surface area, we use the entire numbers that are in our calculator. We rounded them to write them down, but again, we always want to use the entire values in the calculator. That's why I stored surface area 1 into memory slot A, so I could do that. And so it's approximately 169.6 square yards. So there's a total surface area of that. So these next two shapes are very similar. They both have a box on the bottom, and they both have a prism on the top. So let's do question C first. Now let's just do question C, that'll be fine. So again, split this up. I'll put surface area 1 on the bottom, and then surface area 2 on the top. So remember, you cannot see where the two shapes are connected. You cannot see the top of the box, nor can you see the bottom of the triangular prism. Can't see them. So you're not going to include them in the surface area. So for the box on the bottom, it's a rectangular prism. You've got a base, which is 3 centimeters by 5 centimeters. And I'm not going to put my units here just to save some room, but I'll add them in after. So that's the base. Then you have the front and the back. Those are squares, actually. They're 3 centimeters by 3 centimeters. So you can clearly see the front. The back is in dotted lines, but it's there. So you have two pieces that measure 3 centimeters by 3 centimeters. And then you also have the left and the right side of the box on the bottom, and they are rectangles. They measure 5 centimeters by 3 centimeters, right? That's 3, that's 3. 5 centimeters by 3 centimeters, and there's two of them. So we can put all these in our calculator at once. 3 times 5 plus 2 times 3 times 3 plus 2 times 5 times 3 gives us 63 centimeters squared. So there's surface area 1. Now the top is a triangular based prism. It has a triangular front and a back. So there's two pieces that are identical. And the height of these triangles is 4 centimeters. The base of these triangles is 3 centimeters. So there are two pieces, two triangular faces. So that's what the first two is. And the formula for area of a triangle is base times height divided by 2. Jackie, you with us? Put your phone away, please. And what happens here is the 2's cancel. 2 divided by 2 cancels. So you're just left with 3 times 4, which is, well, actually, let's continue on. Let's continue on here, because that was just the front and the back. We're going to have the right side of this top piece, which is a rectangle. It is 5 centimeters wide by 4 high. So I've got the front and the back. I've got the right side. But then there's also this slanted face that you can't see. And that's what this 5 represents. It represents the width of that. It's going to be 3 by 5. So that's the slanted piece on the left side that you can't even see. It's not visible, but we know it's there. And it is 3 by 5. Actually, I'm sorry, that's not right. It's 4 by 5. Because it's going to go along here. No, I'm not. That's not right either. It's 5 by 5. Because it's going to go along here, and this piece is 5. It's 5 by 5. So I apologize for that. So what do we have here? We have 3 times 4, which is 12 centimeters squared, plus 5 times 4 is 20 centimeters squared, and 5 times 5 is 25 centimeters squared. So that should be 57 centimeters squared. And then our total surface area is found by adding these together. So 63 plus 57 is 120. So there's the area of all those faces added up. And question D is virtually the same. You've got a box on the bottom. You've got a triangular prism on top. But where the two connect, you wouldn't count that in surface area. You cannot see the top of the box, nor can you see the bottom of the triangular prism. So let's do this one. Again, I'll put surface area 1 on the bottom, surface area 2 on the top. And surface area 1, if you pick that shape up and turn it upside down, you'll be able to see the very bottom of it. So we have to include that, 35 by 10. So that's the bottom. Then you have the front and the back. The front and the back measure 35 by 20. And there's a front and the back. There's 2 of them. So that represents the front and the back. Then you have the left and the right. They're smaller rectangles, but they measure 10 wide by 20 high. The left side is the same. So again, there's 2 of them. So twice 10 by 20. So we can put this in our calculator. 35 times 10 plus 2 times 35 times 20 plus 2 times 10 times 20. 2150, exactly. And that'll be in centimeters squared. So there's surface area 1. Surface area 2 now. The very front of the top piece is a triangle. It has a base of 35 and a height of 20. And then there's a back piece that's the same. So there's 2 of these triangular faces. There's 2 of them. That's why I have this 2 here. Times the base of 35 times the height of 20 all over 2. The formula for area of a triangle is base times height divided by 2. And then in this case, the only other pieces we have are this piece on the right side that is a rectangle. It measures 10 by 29, and there'll be one on the back side that you can't see, another rectangle that measures 10 by 29. So there's 2 of them, 2 pieces that are 10 by 29. So this first term, the 2's cancel, 2 divided by 2 cancels. So all we're left with is 35 times 20 plus 2 times 10 times 29, which is 1280 centimeters squared. And so now we're going to add these 2 together to get our final answer. $34.30 is our final answer for the surface area of that composite shape. Okay, So I'm going to hand out assignment 7.6. I will post the solutions on Google Classroom so you can check your answers. Remember, Thursday is the last day to hand in any missed assignments. Also, our final exam is Friday morning, this coming Friday, January 20th, 8:30 in here. So again, I would recommend that you put that in your phone so you don't forget. And if you have Social 10, then you'll be here Thursday afternoon for your Social 10 exam. You guys shouldn't have anything on Friday because it's English 30 and Social 20. So the exam schedules are posted online. I've got one at the back there. I've got a big one up here. If you want to take a picture of it, you can. But it's your responsibility to know where you're supposed to be and when. What do you want, Keen?